Here we have to name the molecule. This one in particular has 3 carbons. We can see here 1, 2, 3. Each of these corners is a carbon. Now, we can see now it's pentane. Now it's hexane. Pretty easy, right? It just goes up like this. Can you guess what 7 is? This is heptane. All of them end with ane. Let's keep working with heptane. But instead, let's add a methyl group on the end of it. How do we name this? It's actually pretty easy. You just count the carbons up, 1, 2, and then there's a methyl. And then we just add the rest of the name. So this is 2-methyl, 2-methyl heptane. Pretty easy, right? Now, let's add another carbon off of that. Oh, that looks a little weird. An ethyl group here. To name this, we just change methyl to ethyl. Pretty easy. It's the same thing if we add 3, this changes to propyl, and then butyl, and then pentyl. Here we have another substituent. Can you guess the name of it? It is actually not 1-methyl heptane, it's actually octane. Why isn't it 1-methyl heptane? Because the chain itself has become 1 carbon longer. This is equal to this. 2, 3, 4, 5, 6, 7, 8. There are 8 carbons in the chain, so it's octane. Don't get that confused. Here we have a molecule with 2 substituents on it. There's 2 methyls at the end of the 2 and 3 carbons. So how do we name this? Instead of naming the methyls individually, we just say this is 2, 3, 2 and 3, methyl butane. 1, 2, 3, 4, that's butane. I've changed the molecule up a little. How do we start naming this? This is where it gets a little tricky. We start with the substituent where its first letter is first in the alphabet. We name it alphabetically. So we start on the side where with the highest order alphabetical, and we start from there. So this is 2-ethyl, 4, methyl, pentane. Here we have a ring of 1, 2, 3, 4, 5, 6 carbons. How do we name this? It's actually pretty easy. When you have a ring, you just put cyclo in front of it. So there's 6 here, so it's cyclohexane. Let's say we add a methyl at the end of one of these carbons, any of these carbons. This becomes 1-methyl cyclohexane. Now we have another substituent on here, another methyl group. To name this, we count the carbons 1, 2, 3, 4. So this is 1,4-methyl cyclohexane. Here we have a triangle molecule. And we see there's 1, 2, 3 carbons in the molecule. This must be cyclopropane. Cyclopropane. We had a methyl on top. This is 1-methyl. Cyclopropane. Here we have a very odd molecule. I'll let you give it a try. Give this a little pause. Try and figure it out for yourself. Okay, so the longest chain here is not this 5-membered group. It is actually this 6-membered chain. 1, 2, 3, 4, 5, and 6. So we know this is a hexane group. Let's redraw it. Make it a little easy on ourselves. 1, 2, 3, 4, 5, 6. You can see on the 2 carbon there's a methyl. And on the 3 carbon there is a propane group. So this is this. So this we know is this is 3 propyl. 2-methyl. Hexane. Pretty easy. Here we have a very strange group here. We can see that it's a cyclo group, but it also has very different substituents. So let's start with the alphabetical order. This is ethane, propane, and 2 methyl groups right here, apart from each other. So this must be 1-ethyl, 3-propyl, 2,4-methyl, cyclobutane. I ran out of space there. These two are supposed to be together. And now you know how to name these simple molecules.